All right. I'm going to need to restart my computer, but I don't want to do that. So, we'll just move it up. Here we go. We're going to do the rotation of conics. Okay? So, essentially, we have been graphing conics either vertically or horizontally. Okay? Well, that's not the only way we can do it. Okay? We could take any one of our three conics and we could graph them at an angle. Okay? So, this ellipse up here is graphed. If you imagine this guy right here, we've rotated it by an acute angle. Okay, and now it's tilted a little bit. Okay, I think way back at the beginning of this chapter, somebody asked me, hey, can we graph them diagonally? Yes, yes, we can. Okay, so how do we know they're going to be graphed diagonally as opposed to straight up and down? Okay, these are the general equations we've been working with. Well, now if we have a rotated conic, you're going to see this xy term. Okay, without the xy term, we have a regular horizontal versus vertical conic. If we have that xy term, we are going to have a rotated conic, which means how we approach the problem is going to be very, very different. So the first thing we need to be able to do is determine which type of conic it is. Okay, let's go back over here. If we do not have an xy term, that's what we did all the way up until yesterday's quiz. Okay, how do I know if we have a parabola? Okay, so we don't have either A or C here. How do we know if we have an ellipse? Okay, we have both of these squares, but they're the same sign. Could we tell the difference between a circle and an ellipse here? Yes. What's the big key? Okay, if these coefficients are exactly the same, we know it's a circle. Like 2x squared and 2y squared, we know it's a circle. Okay, and then a hyperbola, what has to be true about A and C? They're opposite. One's positive, one's negative. Okay, now that all goes out the window when we have this xy term. Instead, okay, you guys have written down ax squared, bxy, and cy squared, right? These three coefficients are going to tell you what type it is. We're going to use b squared minus 4ac. That should sound familiar from a particular formula that we have. What formula is that from? What is it? The quadratic formula. It's what's under the radical. Okay, we call it the discriminant. You might remember that. So if we take b squared minus 4ac and compare it to 0, these are our three different options. Write them down because you'll need to know how to identify. Now you're welcome to still use this if we have a regular conic. You just wouldn't have a B because there's no XY term, but it'll still help you. But I think it's more work than just looking at the coefficients, okay, but it's not a problem. The only thing is if it's a rotated conic, we will not know the difference between an ellipse and a circle until we get to our final step. if it is a regular horizontal vertical conic, we do know the difference between an ellipse and a circle. Okay, so that's something I will expect you to be able to do, is tell me the difference between an ellipse and a circle if it's horizontal vertical, but if it's rotated, we cannot. Okay. I am going to show you how to, or we're going to go through a couple examples to determine what type of conic it is. And then we're going to go through the process of rewriting our equation so we can imagine what it would look like on a graph. Okay. So our first example, 2x squared minus 3xy plus 2y squared minus 2x equals 0. Okay. First of all, I see that we have an xy term, so I know that it is a rotated conic. Okay. Because of that, really the only numbers that matter are a x squared, b xy, and c y squared. I guess I should do capital letters. Okay, so b squared minus 4ac. B is the coefficient of xy. A is the coefficient of x squared, and c is the coefficient of y squared. What does this equal? Really doesn't matter what it equals, right? This is 9. This is more than 9, right? 9 minus 16. I really don't care what it equals necessarily. I care how it compares to 0. So we know 9 minus 16 is going to be a negative number. Don't really care what it is. We just know that it's negative. And because it's negative, what do we have? Okay? We have an ellipse or a circle. Okay? We're not sure which one. We'll be able to tell once we rewrite our equation. Okay? But we don't know yet. Second example, x squared minus 6xy plus 9y squared minus 2y plus 1 equals 0. Since we have an xy term, we know it's a rotated conic. Therefore, we must use the discriminant. Okay. So b is that coefficient of xy. B squared minus 4. A is always the coefficient of x squared, and c the coefficient of y squared. What is that? 0. Which means it is a parabola. Okay. And then I'm not going to go through our third example because I feel we're getting a little bit redundant here, and we're going to actually do this within the long problem that we'll do. But if that discriminant is greater than 0, then we're going to have a hyperbola. Okay? So b squared minus 4ac, you just need to be able to remember if it's positive, 0, or negative, which one is it going to be. Okay. Now, I promise you that what we write down on this next slide will make more sense as we go through a problem. It might kind of look like gibberish right now. Okay? But essentially what we're going to do is over here, we're going to call this, we're basically going to create a new set of axes that's tilted. Okay? So you're going to see some x primes and some y primes. Essentially what's happening is we're going to take the x-axis, we're rotating it, whatever that theta is, and we're going to call it x prime. Same thing with y. Y gets rotated to y prime. So when you see these x primes and y primes on the next slide, we're essentially going to rewrite our equation so we can graph it on that tilted axis instead of using xy coordinates. Okay? So, we have a problem when we have that xy term. We cannot just like complete the square because we have a term that has x and y in it. So what our process is going to be, we're going to take this equation and we are going to rewrite it in terms of x prime and y prime. Therefore, A, we don't have an xy term, and B, we can graph on that tilted axis instead of the xy normal axis. How do we do that? There is a method. We don't just like magically change things around. Okay. We first need to figure out what the angle is. And then we're going to make some substitutions for x and y so we can change things to x prime and y prime. So we're going to rotate counterclockwise by theta. Here's how we determine theta. You could use tangent or cotangent, but I feel that we're all probably more comfortable with tangent. So that is the one that I would probably write down instead. If you would like to write down both, that's fine. If you would like to use cotangent instead, that's fine. But I'll probably use tangent because I feel that our brains think of that probably more often than we do cotangent. We are going to get this into x primes and y primes by making these two substitutions. Trig is coming back full force in this chest. No, you don't have to. She nodded. Yeah, I nodded like yes, you're gonna have to remember. I can't remember. It's you will use it enough to where okay. Here's something that I like to think of. Okay, x is our horizontal. We associate it with cosine, so cosine comes first, right, and then sine. Y is our vertical. We think of sine associated with y, so sine comes first there. Okay. Subtraction in the first. I mean, that's how you can remember it. There is a lot of math behind this. Not something we're going to get into of the whys and hows. but for right now, you just need to remember that that's the substitution to make. Okay? So, there's some trick here. We're going to have to remember our unit circle. Okay? Don't write this down because you have the unit circle in a number of different places, but I want you to remember that in the first quadrant, here at 30 degrees, radical 3/2, 1/2 is our coordinate. Here at 60 degrees, 1/2, radical 3/2 is our coordinate. And here at 45 degrees, radical 2/2, radical 2/2. Okay? You'll need those three angles. I'm just saying it right now. Okay. Oh, was everyone done writing down what they needed to here? And yeah, I'm just so excited to get to the example. All right, here it is. We're going to start off simple and then we'll get to your homework problem and go through that.
All right.
Well, one thing at a time. Just write down the problem first. Nick, thank you. We have to figure out what type of conic it is. A, we know that it's rotated because of the xy term. Okay. So, yes, we need to figure out what type of conic it is. And technically that should be our first step no matter what. But, you know, when we're working in standard form, it's a lot more obvious, right? Okay, so b squared minus 4ac. What is our b? 1, because it's the coefficient of xy. What is a and c? There's not an x squared or a y squared. So that's positive. Awesome. What do we have?
Oh, this is the hardest one.
You know what? But we're not actually going to graph it today. Okay? So maybe I should make that clear. We're not going to graph them today. We're going to graph them on Monday. Okay? All right. Step number 2. We need to figure out how much is this hyperbola being rotated. Where is our x prime, y prime axis going to be? Okay? So, we have tangent of 2 theta equals...
Why? It said 20. I'm pretty sure it said 20.
I'm pretty sure it's 2 theta. You just didn't see the seatbelt. Or the
I'm pretty sure it said 20.
Okay. So we have the tangent of 2 theta is b is 1 over 0 minus 0. What's 1 over 0? It's undefined. Okay. Do we have a place where the tangent is undefined? Yes, we do. Okay? So, first of all, when you're considering your angles, you always want to go with the closest when you're doing clockwise. So I know that there are 2 places the tangent is undefined, but the first place when we're going clockwise is where? Number 2. Okay. So 2 theta is pi over 2, which means theta is pi over 4. And you're all smiling because pi over 4 is probably the best angle out of the 3, right? Yes. Okay. Yes. Did I say clockwise? I did say clockwise. I'm sorry. Counterclockwise. Thank you for that. Okay. Counterclockwise.
I was trying to think of a clock. Did you know Miss Lindsay has a clock that goes backwards?
Really?
Yeah, I was staring at it for like 5 minutes during the ACT. It was quite distracting. Trying to figure out what time it was.
Counterclockwise. I'm so sorry that I said clockwise. Okay? Counterclockwise. Okay, our third step is we have to figure out what x and y are going to be. Okay, so our x substitution is x prime times the cosine of theta minus y prime times the sine of theta. Okay? Obviously, you're not going to leave it like that. We can actually evaluate those numbers. So your x substitution is going to be radical 2 over 2x prime minus radical 2 over 2y prime. If you're rusty on your unit circle, it would not hurt for you to look at it again during the weekend. Okay? Our y substitution is going to be x prime sine of theta plus y prime cosine theta. So our y substitution is radical 2 over 2x prime plus radical 2 over 2y prime. Okay. The whole point of this, algebraically, is to get rid of what pesky term? xy. We should no longer have an x times y when we are done with this mess. Okay? And you can call it a mess. I'm not offended by that. Okay? Also, we are writing it in terms of when we actually go to graph it, here's our xy axis, right? Well, at counterclockwise, a 45-degree angle here's our x prime y prime axis, so we're going to graph it on that blue set of axes. Okay, not today, do later. Okay, but that is our goal. So where are our substitutions? So step 4, where are we? xy minus 4 equals 0. We're actually going to make these substitutions. So we're going to throw in radical 2 over 2x prime minus radical 2 over 2y prime for x. And then we're going to throw in radical 2 over 2x prime plus radical 2 over 2y prime for y. Okay. You are going to make any multiplications. We're actually going to distribute and do all of that fun stuff. Then, knowing we have a hyperbola, we need to get it in standard form for our hyperbola. Okay? So, let's do this. We have radical 2 over 2x times radical 2 over 2x. 1/2 x prime squared. Marissa, you good? Yeah. Okay. Radical 2 over 2x prime times radical 2 over 2y prime. Negative radical 2 over 2y prime times radical 2 over 2x prime. And then negative radical 2 over 2y prime times positive radical 2 over 2 minus 4 equals 0. Yes?
Wouldn't that be minus 1 squared?
Yep. What happens? Okay, this should happen. If your XY terms don't cancel out, you have done something incorrect in your algebra somewhere. They should always cancel out. Okay? So what we have is we have 1/2 x prime squared minus 1/2 y prime squared. I'm going to move that 4 over equals 4. But hold on. If we have a hyperbola, what should it equal? 1. It should equal 1. So we're going to have to divide this by 4 to get x prime squared over 8 minus y prime squared over 8 equals 1. Voila. Yes. Yes, it was. What we'll do on Monday is we'll actually take this hyperbola equation, identify the center, identify the vertices, identify the asymptotes, and graph it on the x prime, y prime axis. Okay, we are going to do one of 4 homework problems. There is a homework problem very similar to this. We're not going to do that one in class. So we're going to start with your 3rd homework problem, number 19. Yeah, you can do this in your notes and then transfer it over. That would be good muscle memory. Okay. Our first step is to identify the type of rotated conic it is. This is a rotated one, right? I'm not giving you a regular one. It's rotated, and Callie, we know that because there's an xy term. Now you see that radical 3 there, and you think, oh, yeah, radical 3. It's actually a good thing because, you know, we have radical 3 as a part of a couple of our nice angles. So it's actually a good thing. Okay, step 1, I'm going to give you 1 minute to identify the type of conic. Work together at your table. Maybe 2 minutes.
Less than 4 times 13 times 7. 36. It's not close at all. It's not even close. It's 28 times 13.
It would take 4 to get that, and you have 13. 4.
Still gonna use my brain.
Unnecessary.
You get a I use the calculator, you know, you're allowed to use the calculator.
Yeah, if you're wasting your time.
You are?
What?
Are you talking about the ACT? What are you talking about?
The ACT.
Oh, okay. I thought you were talking about the test. So
What?
Yeah, no calculator on the test.
What do you mean? On the math portion, you can use the calculator.
On the ACT, we're not talking like about test.
Oh, no.
Calculator, so
Put it away.
Put it away.
6 radical 3 squared is the same thing as 36 times 3, right? And 13 times 7 times 4 is that. Okay, so what kind of number do we have? Like positive, negative, or 0?
Oh, it's negative.
It's negative. So what does that mean, Maverick? Okay, it's an ellipse or a circle. We're unsure. Okay, so make sure you put, it could be either. Okay, step number 2, we need to identify the angle. the tangent of 2 theta is b over a minus c. Okay? You first need to figure out what 2 theta is, then divide by 2 to figure out theta. So I'm going to give you a couple minutes to, at your table, figure this out. I'm going to pause the video so that this isn't like...
No,
It's not. Wait, hold on. I don't remember which one. So radical 3.
Okay, so your ratio is 6 radical 3 over 13 minus 7. So basically, radical 3, right? Okay, Courtney went into the tangent, radical 3. Pi over 3, some of us, it took us a little bit to recall that. Okay, I realize that we're going to be a little rusty right now, but know that by test time, Thursday, Friday, we need to be on point with our unit circle, okay? So theta would be pi over 6. All right. Now let's figure out what our substitution. Remember, x and y have those formulas. I'm not going to write them down. I want you to go through the process of finding them, recalling them, whatever. But I'm going to give you a few minutes to go through that. All right, Richard, what is our x substitution going to be?
Radical 3 over 2 x prime minus 1/2 y prime.
Do you agree?
Yes.
Okay. Lindsay A, what's our y substitution then? Okay, well, let's go through it together. What is the sign of pi over 6? So we have 1/2 x prime. Plus, what's the cosine of pi over 6? So we have radical 3 over 2. What? Okay. At this point, I'm going to transition to the whiteboard. Okay, so those of you watching from home, this is where I'm going to stop.